Right, so this video is on addition formulae. Right, so for any two angles A and B, if you take A plus B or if you take A minus B, they are known as compound angles. And as such, the trigonometry ratios obtained from the addition formulae can be summarized as what is shown on the screen there for sine, cosine, and tangent. So we'll be using this addition formulae to do some problem solving. Right, so addition formulae can be applied in this context here, where you ask to solve the equation cosine bracket theta plus 30 degrees equals to sine theta. So before we solve this question, let's write down the addition formulae for cosine. Cosine bracket A plus B will give you cosine A cosine B minus sine A sine B. And cosine bracket A minus B will give you cos A cos B plus sine A sine B. All right, so we're going to use the first one to simplify cosine bracket theta plus 30. So before we use the addition formula, let's talk about some special angles. So what are the special angles? They are 30, 45, 60. Right, so why are they called special angles? They're called special because when you use your calculator to evaluate the trigo ratio of these three angles, right, the answers you get will be either a rational number or you can express it in surd. But any other angles, any angles that it's not 30, 45, 60, you realize that if you use a calculator to evaluate the angles, you will get irrational number, a lot of decimal places shown on your calculator panel. Right, so to give an example, if you use your calculator to evaluate sine 30, right, you will get half. But if you evaluate sine 29 or sine 26 or sine 129, things like that, you have a lot of decimal places. Right, so another value that will gives you an exact value, that means you can express it in surd, it's cosine 30. Right, so if you use a calculator to evaluate cosine 30, yes, you will get a lot of decimal places, 0.866, but this 0.866, this irrational number can actually be expressed in a surd form. So how do you find the values for it? So there's a shortcut to do it. So instead of finding cosine 30, right, you actually go on to find cosine squared 30. So what is cosine squared 30? Cosine squared 30 is just basically cosine 30 times cosine 30. So if you use a calculator and then you key in cosine 30, right, times again cosine 30, on your calculator you'll get 3/4. Right, so cosine squared 30 is 3/4, hence cosine 30 will just square root of 3/4. And square root of 3/4, you can apply the rule you've learned earlier on in the chapter on surds. Will give you square root 3 over square root 4. So square root 3, you leave it at square root 3 because this is our objective. Our objective is to leave the answer in surd. Right, so square root 3, leave it in surd, and square root 4 is 2. Right, so cosine 30 is equals to square root 3 over 2. You can do that for sine 45 also. If you use your calculator to evaluate sine 45, right, you will have a lot of decimal place, 0.70, blah, blah, blah. Right, but you can actually find sine squared 30 instead. Sorry, sine squared 45 instead, which is just sine 45 times sine 45. And that gives you half. So therefore, sine 45 will be 1 over square root 2. Or if you rationalize it, it will be square root 2 over 2. So it only works for all these three angles, 30, 45, 60. You can try it for sine 29. Sine 29 times sine 29. Alright, you won't get a rational number. You will get 0.235, blah, 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 but there's no way. Alright, you don't get a rational number at all. So it only happens on these three these three angles, 30, 45, 60. That's why they are called special. Alright, so let's get back to the original question. So I can replace cosine 30 as square root 3 over 2. And then I can replace sine 30 as half. Alright, so the next thing I'm going to do is to group all your sine theta together and then the cos theta on the other side. Alright, so I'm going to multiply by -2 on both sides, -2 on both sides. So you end up 3 sine theta equals to square root 3 cos theta. Alright, so you still cannot solve this trigo equation, right? Because it involves two different trigo functions, sine and cosine. So what connects sine and cosine? Yes, it's a ratio identity. Tangent theta. Right, tangent theta is equals to sine theta over cos theta. So what I've done there is to divide both sides by 3 cos theta to convert it into tangent theta. So tangent theta is equals to square root 3 over 3. Right, so the next step is to find your reference angle, which is tangent inverse square root 3 over 3, 30 degrees. And then your ASTC. So for tangent to be positive, the angle can be found in the first and the third quadrant. So first quadrant will just be alpha itself, 30 degrees. Third quadrant will be 180 plus alpha, which is 180 plus 30, 210 degrees. So this is one example on how you can actually use addition formula, right, to solve trigo equation. Okay, the next kind of questions that you can actually use addition formulae, it's what is shown on the screen. All right, so we're going to use addition formula to simplify that. So that will give us sine 2a cosine b minus cosine 2a sine b over sine 2a cosine b plus cosine 2a sine b equals to 3/5. Right, so we're going to do a cross multiply. Right, simplify it. Right, group all similar terms together. So I have one guy here that's similar. It's a what do you call that? Term of the same kind because it involves sine 2a and cos b. Right, so I put them together on the left hand side. That will give me 2 sine 2a cos b. And this guy here is similar in nature to this. Right, so I put them together on the right hand side. That will give me 8 cos 2a sine b. Alright, so the next step is that remember your ratio identity, which is quite commonly used. So you have to try to remember it, and that is sine a. You can express sine a over cos a to be tangent a. So this is what I'm going to do. I'm going to divide both sides. Okay, divide both sides with 2 cos 2a cos b. Right, so that will give me tangent 2a on the left hand side. On the right hand side will give me 4 tangent b. Okay, right, so I'm going to call this equation 1. I will need it later on. So what's the next piece of information that I can use from the question? Yes, if you look at it carefully, all right, you are told that you can only find the values of tangent b if you're given this condition. So I'm going to use that condition to help us find the value of tangent b. So from what you're given there, okay, we can apply the addition formulae for tangent. So that will give us tangent 2a plus tangent b over 1 minus tangent 2a tangent b. equals to 1. Alright, and can you see that we have found tangent 2a in terms of tangent b in equation 1. So this is what we're going to do. We're going to substitute tangent 2a with 4 tangent b. So I would get... Right, let's continue on what we have left in the earlier slide. Right, so I have substituted tangent A to be 4 tangent B. So let's continue to simplify it. So 4 tangent B plus tangent B will give you 5 tangent B. And then 1 minus 4 tangent B times tangent B will give you 4 tangent squared B. Right, so you multiply the numerator, multiply the denominator. Alright, then you can do a cross multiply. So that will give you 9 tangent squared B equals to 1. So tangent squared B equals to 1 over 9. So tangent B can be positive 1/3 or negative 1/3. Right, however, there are some conditions that you need to satisfy. So what are the conditions? Right, so the conditions that you need to satisfy is the angle B must be between 90. Pi over 2 is 90 degrees because 180 is pi. So 180 divided by 2, it's 90. So angle B must be between 90 to 180. So between 90 to 180 will be in the second quadrant. That means your angle B must come from the second quadrant. So if you were to, again, use your ASTC, right? Only sine is positive in the second quadrant. Tangent is negative. Right, so tangent is, so since your angle B must be between pi over 2 to pi, tangent B is negative in the second quadrant. Right, so we managed to get 2 answers for tangent B. Right, we managed to find 2 values for tangent B, which is 1/3 or negative 1/3. But from our reasoning, as shown above, tangent B has to be negative in the second quadrant. So hence we reject this guy. We reject the positive value for tangent B. And we put tangent B equals to negative 1/3 as our answer.